This is half past paper week 16 and it is a big one. So we had only 33 marks on last week's paper, which means that this week is 47, all the even numbers. Just happens to be a lot of big markers that fell on the even numbers this week. So strap in, it's going to be a slightly longer one, I think. So let's go. Question number 2, and we've got set notation. So this funny squiggly E, what does that mean? Well, that means the universal set. So I need you to think of that like it's everything in the world that you know about right now. That is your universe. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is your whole universe. That is everything you know about right now. If I started asking you about the number 11, you'd say, no, that's not in my universe. I don't know about that number. That's not in my universal set. So we've got A is all the even numbers, but remember that's only even numbers from within your universal set. So we've got 2, 4, 6, 8, and 10. We wouldn't put 12 because that's not in our universal set. And then B, factors of 10. So we've got 1 and 10. Don't forget factors come in pairs. And 2 and 5. There we go. Those are all of the factors of 10, numbers that fit into 10 an exact number of times. Okay, let's go ahead and complete the Venn diagram for this question. So looking at A and B, first I'm going to think about what numbers could go in the intersection, which is that middle bit. So I've got 2, that's in A and it's in B, and I've also got 10 that's in both. So I'm going to put 2 and 10 in the middle. For A, I've got 4, 6 and 8 left over. And for B, I've got 1 and 5 left over. Now, a lot of students stop there, and that's going to lose you marks. Your universal set, this funny squiggly E, is also up here. And that box that's around the 2 circles needs to contain all of the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for you to get full marks. So we know they're not in A and B, but therefore we need to put them on the outside. So I'm just going to go through 1, 2, and then 3 will go on the outside. I've got 4, I've got 5, I've got 6. 7 will need to go on the outside, 8's there, 9 will need to go on the outside, and 10 is there. And then always just do a check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I've got everything. So I definitely know that I will get full marks for that one. Okay, fabulous. That's 3 marks. Moving on, a number is chosen at random from the universal set. So we're choosing at random from the universal set, and that has 10 numbers in it. So I know that this probability is going to be out of 10, and that's going to get you a mark just for having a fraction. As long as the top number makes sense, that bottom number being out of 10 is going to get you a mark. Find the probability that this number is in the set A intersection B. So you've got 2 things that they normally ask you. Either this, which is the intersection, which is asking you what's the probability of it being in that bit there, or sometimes they'll ask you the union, which is when it's that way up, and that means what's the probability of it being in either A or B. So then it can be across either of them, okay? So in this case, we want to know what's the probability of it being in that intersection, and there are 2 numbers in that intersection out of the 10 possible numbers, so 2 out of 10. Sometimes people simplify it. I would say don't bother. With probability, you never need to simplify it, and also if we simplify it and we were wrong, we might lose that 10, so we want to definitely make sure we've got a mark for that and a mark for that, so I'm happy to leave it as 2 over 10. If you did put it as 1 over 5, you'd still get full marks, but if you were incorrect in your simplification or they couldn't see the 2 out of 10, you might risk losing both, so I would just leave it like that. If this had been the question, what's the probability of it being in the union, which is either A or B, we've got 1, 2, 3, 4, 5, 6, 7 numbers in the union, so then it would have been 7 out of 10. So that would have been the answer if that had been the question, but in this case we had the intersection, so 2 over 10. Okay, question number 4. Complete the table of values for y equals 5 minus x cubed. Now there's a few different ways you can do this. This is a calculator paper, so you can use your calculator, and there's a table function, and I will do a separate video on that. Personally though, this could come up on the non-calculator paper, so it's a really good idea to know how to do it non-calculator as well. So for non-calculator, we need to think about substituting this value of x into the formula for each of the values of x. So I'm going to start by doing 5 minus 2 cubed. And minus 2 cubed means minus 2 times minus 2 times minus 2. Minus 2 times minus 2 is 4, times that by minus 2 is minus 8. So we're doing 5 minus minus 8, and that becomes an add. So this one is 13. Then I'm doing for 0, 5 minus 0 cubed. 0 cubed is 0 times 0 times 0, so 5 take away 0 is just 5. Then for 1, I'm doing 5 take away 1 cubed. 1 cubed is 1 times 1 times 1, so 5 take away 1 is 4. And then last but not least, I've got the 2, so I'm going to do 5 take away 2 cubed. 2 cubed is 8, and 5 take away 8 is minus 3. So now I've just got coordinates that we need to plot. There's one coordinate, there's another coordinate, and so on. So I'm going to do minus 2, 13, which is here, minus 1, 6, which is here, 0, 5, which is here, 1, 4, which is here, and 2, minus 3, which is down here. And then we're going to join that up with a nice smooth curve. There we go. There's my cubic. So it's a negative cubic. You've got that x cubed, which makes that kind of wiggle shape. And because the x cubed is negative, that's why it's coming downwards rather than going upwards. There we go. That's it. 4 marks for that one. Question number 6. A equals 3, 4, and B equals 5 minus 2. Find 2a minus 3b as a column vector. Okay, so both of these are vectors, and vectors are instructions. The top number tells you how much to go left or right, and the bottom number tells you how much to go up or down. So for example, the vector 3, 4 means 3 right, and then 4 up. The top number is left and right, positive being right, negative being left, and the bottom number is positive for up and negative for down. In this case though, they just want us to combine them. So we've got to do 2 lots of this instruction, take away 3 lots of this instruction. Now these are not fractions, so normally I'd say, right, hang on, if we're subtracting fractions we're making the denominators the same, but these are not fractions. You can treat them completely differently. They're not fractions, okay? So we've got 2 lots of this. First I'm just going to change that to 6, 8. I've doubled the 3 and doubled the 4, and then I'm taking away 3 lots of that one, so that's 15 minus 6. Now, we can just do 6 take away 15, which gets me minus 9. And then I can just do 8 take away minus 6. Now remember that minus minus is going to become a plus. So 8 add 6 is 14. And there we go. Minus 9, 14 is our answer for 2 marks. Question number 8. Tariq buys a laptop. He gets a discount of 5% off the normal price. Tariq pays £551 for the laptop. Work out the normal price. Okay, so this is reverse percentages. He has had 5% taken off, which means that £551 equals 95%. That is 95% of the value. So we need to work backwards here. And there's a couple of ways you can do. Because this is a multiple of 5, I could very easily get to 5%. And I can do that by dividing by 19. If I divide that side by 19, I'd also have to divide that side by 19, and then I can times that by 20 to get back to 100%. That's one way of doing it. Another way of doing it is to say, well, I had an amount of money, however much the laptop was, I timesed it by 0.95, and the answer was £551 because I wanted 95%. And when we want 95%, we times by 0.95, and therefore, if you want to work backwards, you can just divide by 0.95. So using my calculator and working backwards here, £551 divided by 19, let's look at that method over on the right, is £29. So you know that 5% is £29, and then multiplying that by 20 would get us back to 100%, which would be 580. So that's one way of doing it. You could also divide by 95 to get 1% and then times that by 100. That would work as well. And then on the method on the left, to get back, all I want to do is divide by 0.95. So in the mark scheme here, they'll be looking for recognition that you understand that you haven't got 100%, you've got 95%. Dividing by 0.95 gives us 580, so there we go. I typed it in the calculator even though I already had the answer, but there we go. £580 would be your answer. That is the normal price of the laptop. Remember, 5% of 580 is not the same as 5% of 551. So you can't find 5% of this and add it on. It won't be the same answer. Okay, Joan invests £6,000 in a savings account, and the savings account pays compound interest at a rate of 2.4% for the first year and 1.7% for each extra year. Work out the value of Joan's investment at the end of 3 years. So we're starting with 6,000. For compound interest, we want to times by 1 point, and then we're going to add on the interest rate. So for the first year, we want an extra 2.4% on our money. So we want 100%, add on 2.4%, which is 102.4%. Now, as a decimal, we divide that by 100, and that's 1.024. So I'm going to times by 1.024. Now, you can do this in 2 stages, or you can do it in one whole stage. It doesn't matter. I'm just going to break it down just for the purpose of this video. So 6,000 times 1.024, and sometimes we put a power here. So if it was for 2 years, we'd say that bit's squared. If it was for 3 years, we'd say that bit's cubed. But this is only 1 year that we're getting this rate. So I just want to times it by that. And that is 6,144. So after that first year, Joan now has 6,144. We're then going to take that amount of money, 6,144, and times it by, well, now for the extra years, the next 2 years, because it's 3 years in total, we're going to get an extra 1.7%. 100% add on 1.7% is 101.7%, which as a decimal is 1.017. Now, if we've already had the first rate for 1 year, and this is a 3-year investment, then we've got 2 more years at this rate. So I'm going to do that one to the power of 2. So take my answer, times it by 1.017 to the power of 2, and that is £6,354.67. It goes on more than that, but I've just rounded it to 2 decimal places because it's money that we're dealing with, so we want to make sure we round it to 2 decimal places. Okay, now be really careful, because sometimes they say how much interest did she earn, in which case our answer would just be £354.67, but it does say work out the value of Joan's investment, so we want her whole value, which is just going to be that, £6,354.67 for 3 marks. That topic is compound interest. Question number 10, and we've got 1 over m squared to the power of 0. Now, for the purpose of GCSE, anything to the power of 0 is just 1. So all you need to put for this one is 1. X to the power of 0 is 1. 5 to the power of 0 is 1. Anything to the power of 0 is 1. Okay, so if you've got something in brackets to the power of 0, that's going to be 1. If I had 3 lots of x to the power of 0, then this bit is 1. But then I'm doing 3 lots of 1. So then in that case, the answer would be 3. But anything raised to the power of 0 is just 1. So in this case, because everything in the brackets there is raised to the power of 0, the answer is just 1. For part B, I've got 8x minus 4 on the top and then x minus 4 squared on the bottom. Now remember what that x minus 4 squared means. When we square a bracket, we're actually writing it out twice. So on the denominator, I have that. And on the numerator, I have that. Now, I don't want to expand this. I think the temptation is to just expand brackets. But to simplify an algebraic fraction, we actually want it factorised. Factorised is better for us because I can see common factors. We factorise to see factors. And so I've got a common factor on the numerator and the denominator of x minus 4. So I can divide the numerator by x minus 4, and I can divide the denominator by x minus 4. And that leaves me with 8 over x minus 4 as my simplified fraction. For part C, everything in this bracket needs to be cubed. Now, there's a couple of ways of doing that. I think a lot of students find it easiest to say, right, that's 3n to the power of 4 w squared times by itself, 3n to the power of 4 w squared, and times by itself again. There we go. So I've got 3 times 3 times 3, which is 27. I've got n to the power of 4 times n to the power of 4 times n to the power of 4, which is n to the power of 12. When we times, we add the powers. And then I've got w squared times w squared times w squared, which is w to the power of 6. So a lot of students find it helpful to write it out like that. Alternatively, you can just say, right, 3 cubed is 27. N to the power of 4 cubed, or when we do a power of a power, we times those powers together. That's where that 12 is coming from. And then w squared to the power of 3, 2 times 3 is 6. So that's where that 6 is coming from. Either way, that should be your answer. It's going to be 1 mark for 2 out of 3 things correct, and then 2 marks if you get all 3 parts of that correct. Question number 12. The graph gives information about the volume, v litres, of petrol in the tank of Jim's car after it's travelled a distance of d kilometres. Find the gradient of the graph. So we've already got 2 nice clear points. Normally when we do gradient, we would make a triangle, something like this, and we do rise over run. You could go that way, or you could do a triangle any way you like. But here, rather than try and find some random points that might give us a nice answer, I'm just going to use the whole thing, because I very, very clearly here know that this point is 27. So I know that this is 27 in this direction, or minus 27 because we're going down because it's a negative gradient. And then I can see here that this is 300. So actually that's going to give us a really accurate answer. Now gradient is rise over run. And you can either just use 27 or minus 27 in 300. As long as you remember at the end, this is a negative gradient. It's coming down. So my gradient is going to be negative here. So if you don't use minus 27, if you just use 27, that's fine. But remember just to have a look at it and think, is this gradient positive or negative? And because it's coming down, it is negative. And that gives me an answer of 0.09. So my answer is going to be minus 0.09. That is the gradient. Now, what does that mean? It says interpret what the gradient of that graph represents. For every one across, the volume is coming down by 0.09. That's what the gradient means, okay? So some students wrote on, it wasn't this one I was marking, it was a different one I was marking, and they wrote how steep the graph is. Yes, that's what gradient is, but we're talking specifically about what is going on here. The fact that every kilometre, every one across, it goes down by 0.09. What does that mean? Well, it means that every kilometre, was it a car? Jim's car travels, it uses 0.09 litres of petrol? Yeah. There we go. So something to that effect. That is what's happening. Gradient means for every one across, what is the change in the graph? And so in the context of this question, we're saying every kilometre that the car travels, every time you go across by 1, it's got 0.09 lower. So that car must be using up 0.09 litres of petrol for each kilometre it travels. Question number 14. Here are two squares A and B. The length of each side of square B is 4 centimetres greater than the length of each side of square A, and the area of square B is 70 centimetres squared greater than the area of square A. Find the area of square B. Give your answer correct to 3 significant figures. You must show where you're working. Okay, so we don't know how long either of these squares are. So I'm just going to say that this one has a side length of x, and therefore because we know that the side of square B is 4 centimetres bigger, I can say that this one is x add 4. Now remember that because they're squares, that would be the same in both directions. So this one would also have a height of x, and this one would have a height of x add 4 as well. Okay, so then we can make an equation. We know that whatever the area of A is, which is going to be x times x, we would need to add 70 to that to get to the area of square B, which is going to be x add 4 times another x add 4. So this is how we'd work out the area of that square B. And we know that this is 70 bigger. So we know that the area of the little square, add an extra 70, gets you the area of the big square. Okay, so now let's expand that bracket. I've got x times x, which is x squared, x times 4, which is 4x, 4 times x, which is another 4x, and then 4 times 4, which is 16. And on the left, I've just got x squared add 70, can't do anything with that. Now, let's solve this. So I'm going to take x squared away from both sides, which leaves me 70 equals 8x add 16. I've just collected these two together to make them 8x. And then I'm going to take 16 away from both sides. 70 take away 16 is a 54. So 54 equals 8x. And then I'm just going to divide both sides by 8. 54 divided by 8 is going to be 6.75. So we know that x is 6.75, but we're not done there. That's got us the side length of the smaller square. They've asked us here for the area of square B. So we know that square B was x add 4 wide and x add 4 tall. So if x is 6.75, I need to add 4 to that. So I know it's 10.75 wide and 10.75 tall. So to get the area, it's going to be 10.75 times 10.75. You could have just done x.75 squared and added 70 as well, that would work. But either way, you should end up with an answer of, let's just put it up here, 10.75 squared, which is 115.5625. They want our answer to 3 significant figures. So remember that 1, that 5, they're your first 3 significant figures. Check the next number, which is a 5, which rounds up. So 116 centimetres squared is going to be your answer for that one, 4 marks. That topic was forming and solving equations. Question number 16. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term. So I'm just going to write this out again to give myself a little bit more space. 10, 21, 38, 61 and 90. And we're going to start with the first difference. So this goes up by 11. This goes up by 17. This goes up by 23. And then this one goes up by 29. And when we do the difference of the difference, this second difference should be the same. So that's gone up by 6. That's gone up by 6 from 17 to 23. And that's gone up by 6. Whatever that second difference is, you're going to half it. Always. We're always going to divide that by 2. And that gives you the coefficient of n squared. So half of 6 is 3. So I'm going to write 3 n squared, and I therefore know that my nth term for this sequence needs to start 3n squared. Now the sequence n squared is all the square numbers: 1, 4, 9, 16, 25. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. If I want 3n squared, I need to take each of those numbers and times it by 3. So instead of 1, I'm going to have 3 in the first position. Instead of 4, I'm going to have 12 in the second position. Instead of 9, I'm going to have 27. Instead of 16, I'm going to have 48. I'm just making it 3 times bigger. So I'm doing the square numbers, but 3 times bigger. And 25 would be 75. We're then going to take that away. So 10, take off this 3. How much more do we need? We need another 7. 21, take away 12. We need another 9. 38, take away 27. We need another 11. 61, take away 48, we need another 13, and 90, take away 75, we need another 15. What is the nth term here? So this nth term is this. What is the nth term here? This is the 2 times table, but made 5 bigger. So this is 2n add 5. And if I collected these two together, so 3 and 7 would make us 10. 12 and 9 would make us 21. So therefore, combining these two nth terms is going to give us our answer: 3n squared add 2n add 5. That is your answer for 3 marks. Question number 18. The diagram represents a solid cone. The cone has a diameter of 20 and a slant height of 25. The circle is drawn around the surface of the cone at a slant height of 10 above the base. The curved surface area of the cone above the circle is painted grey. Work out the area of the bit that's not painted grey. Give your answer as a multiple of pi. So we want to work out the area of this bit, the wrapped around bit at the bottom that isn't painted grey. So first thing we're going to do is pop 15 up here, because I know that if there is a slant height of 25 on this side, we're 10 above the base here. I know that a smaller cone at the top has a slant height of 15. I'm now going to work out, I know that the radius of the big cone is 10, because just the radius goes from the middle to the edge. If it's 20 all the way across, we can half that, and that's 10. I just want the radius of this bit. Now this is similar shapes. The whole cone, the big thing, is just a bigger version of the smaller cone, the top grey bit. Okay, so we're going to use scale factors here, and the scale factor I can use, I know that the slant height here is 25 and the slant height here is 15. So 25 over 15, which is 5 over 3. So that is your scale factor. You can write it as a decimal, but be careful with recurring decimals that you don't then type them in your calculator wrong. So if I want to know what the radius of this smaller cone is, I'm going to use the 10, and because we're going from the big to the small, I'm going to divide by 5/3. So 10 divided by 5/3 is going to be 6. So this has a radius of 6. And then all we're going to do to get the missing area, we've got the formula here. So I'm going to do the big cone, pi times the radius times the sloped side, pi times 10 times 25, subtract the smaller cone, pi times 6 is our radius of that one, times by the sloped length of that one, which is 15. So we're doing the whole thing, subtract the top thing, and that gives us 250 pi, subtract 90 pi, which gives us an answer of 160 pi. Don't press that SD button. We were asked to give our answer as a multiple of pi, and therefore that is your answer, 160 pi. Question number 20. There are only red and yellow sweets in a bag, so only red and yellow. There are n red sweets in the bag, and there are 8 yellow sweets in the bag. Sajid is going to take at random a sweet from the bag and eat it. He says that the probability the sweet will be red is 7/10. Show why this cannot be the case. So the probability of taking a red sweet is going to be n out of how many sweets are in the bag altogether. Well, there are n red sweets and 8 yellow sweets. So total would be n add 8. He's saying that that equals 7/10. Now, that might have been simplified. It might be 14 out of 20. It might be 21 out of 30. We don't know. But can n over n add 8 equal 7/10? Well, let's solve it and see. So I'm going to start by multiplying both sides by n add 8. That's going to get rid of the denominator over here, but it's going to put it up here on this side. And then I'm going to multiply both sides by 10, which is going to put this up here. So 10n equals 7 lots of n add 8. And expanding that bracket, I have 10n equals 7n add 56. Taking 7n away from both sides, 3n is 56, and that does not divide by 3. 56 over 3 is not an integer, so that cannot be correct. We can't have a decimal number of sweets. Let's just be really explicit about it. 56 divided by 3 in my calculator is 18.6 recurring. So that's no good. You can't have 18.6 recurring red sweets. After Sajid has taken the first sweet from the bag and eaten it, he's going to take at random a second sweet from the bag. Given that the probability that both the sweets he takes will be red is 3/5, work out the number of red sweets in the bag. So this is kind of probability tree, but we actually don't need to draw it all out. I've got him taking a red or a yellow the first time, and then the second pick would either be a red or a yellow, but the only branch that you are interested in is this one here. So the probability of taking a red the first time times the probability of me taking a red the second time, and we know that the answer to that is going to be 3/5. The probability of taking red the first time is n over n add 8. Times by, now if I want to take another red, I've got one less red in the bag and one less sweet in the bag overall. So the second pick would be n minus 1 red sweets out of n add 7 sweets, and that equals 3/5. Let's just work that through. So timesing fractions is top times top, bottom times bottom. So I've got n squared minus n, because I'm doing that times that and that times that. And on the denominator, remember you've got 2 terms times 2 terms. So it's going to be n squared add 7n add 8n add 56. And that equals 3/5. So n squared minus n over n squared add 15n add 56 equals 3/5. We can do the same thing we did in part A and multiply those denominators up. So the next line of your working is going to be 5 lots of n squared minus n equals 3 lots of n squared add 15n add 56. And let's expand that out. 5n squared minus 5n equals 3n squared add 45n add 168. Now I want to get everything on one side and I want for it to equal 0 because this is a quadratic. So I'm looking at the fact that I've got 5n squared and 3n squared, and I'm thinking, right, let's take away 3n squared from both sides and get all our terms on the left. So 2n squared, now let's take 45n away from both sides, minus 50n, and then let's take 168 away from both sides, and then it equals 0, which is what we want for a quadratic. But all of these terms are in the 2 times table. So I'm going to divide both sides of my equation by 2, just to make it a little bit easier to factorise. So n squared minus 25n minus 84 equals 0. Now, does that factorise? Yes, it does. So I've got n minus 28, n add 3, equals 0. And that's going to give us 2 solutions. Either n equals 28 or n equals minus 3. Does it make sense to have a negative number of red sweets here? No, it does not. So we're going to go with n equals 28. That's the number of red sweets in the bag. So 28 on the answer line would be your answer there. Question number 22, last one on this paper. C is a circle with centre at the origin. A tangent to C passes through the points minus 20, 0 and 0, 10. Now I have to immediately draw these questions. I cannot visualise it otherwise. I find it really helpful just to draw it out. So we've got a circle centred at the origin. Don't judge me for my wonky circle. And it goes through a tangent to C, passes through the points minus 20, 0. So minus 20, 0 is going to be, I don't know, somewhere over here. And 0, 10. So let's say that that's up here. And the reason that I'm going slightly beyond the circle is if they are on the tangent, then I know the tangent's just going to touch the edge of the circle and carry on going. I should have drawn the tangent first, but oh yeah, no, I definitely should have drawn the tangent first. Here we go. Let's draw the tangent over here. And so we're going to say that it touches there and it touches there, and that point is 0, 10, and that point is minus 20, 0. There we go. Work out the equation of C. So they want the equation of the circle. C is the circle, okay? What is the equation of a circle? Well, we know the equation of a circle is x squared add y squared equals the radius squared. And we would leave the x and we'd leave the y. It's centred at the origin, so we know that's going to happen. We just need the radius. We just need to know the radius. Now, it's always helpful to draw the radius at the point where it meets the tangent, because you know that those two things are perpendicular. So I really need to get the value of this coordinate here. That's going to be really helpful to me, because then I'll be able to work out how long that radius is from the origin to that point. And I think what I'm going to need to do here is simultaneous equations using the equation of the two lines. So what would the equation of that line be, and what would the equation of that line be? And then we can look at the point where they intersect. Now, to get the equation of the tangent, we can work out the gradient by doing rise over run. So to go from minus 20, 0 to 0, 10, the rise is 10 and the run is 20. It's a positive gradient. So 10 over 20 would be the gradient of that tangent, which is a half. So I know that the equation of that line is y equals a half x plus c, where c is the y-intercept. But luckily for us, they've actually given us the y-intercept. We can see it crosses at 10. So let's just pop 10 there, plus 10. That is the equation of that tangent. What would the equation of the radius be then? Well, we know that if two lines meet at a right angle in the way that a tangent and a radius does, then they're going to be perpendicular. And therefore, if this one has a gradient of a half, the other line here is going to have a gradient of minus 2. And it goes through at 0. So it's going to be y equals minus 2x plus nothing. It's going through at the origin, so we're not going to have a plus c on that. It's just going to be plus 0, which we wouldn't write. Therefore, we're now looking, where do those two lines intersect? So where does the line y equals minus 2x cross the line y equals a half x add 10? And I'm going to write half x add 10 equals minus 2x. I'm making them equal each other. We're going to start by adding 2x to both sides. So 2.5x equals, and I'm going to take the 10 away so it's on the other side. Minus 10 divided by 2.5 is going to be minus 4. So dividing both sides by 2.5 or 2.5, we get minus 4. I now know then that the x coordinate here is minus 4. And to get the y coordinate, you can either substitute it into this equation, or you can substitute it into this equation. I think that bottom one's going to be easier. Minus 2 times minus 4 is 8. So y equals minus 2x. Because that point lies on that line, I can substitute that in. Minus 2 times minus 4 is 8. So therefore y equals 8. And that's that point there. Now, to get the length of this radius, I know that it is 4 across in this direction and 8 up in this direction. So we can just use Pythagoras. 4 squared add 8 squared is 16 add 64, which is 80. And so the radius would be the square root of 80, but don't forget that we need to square it for the formula, so we're going to just keep the 80. So the equation of the circle is x squared add y squared equals 80 for 5 marks, and that was 47 marks altogether. Rather a big paper this week, so hopefully you managed to keep up with me. That last question, really challenging, very much grade 9. Those last couple of questions, really very much grade 9 questions. For this one, if you want more practice on this one, there was a question that went viral from the old specification, and it was actually called Hannah's Sweets. So if you want to go and do more questions just like this one, Google Hannah's Sweets. That was a question that went viral a few years back for Edexcel. There we go. That's the paper. I hope you found it helpful, and I will see you guys next week for week 17.